Hello, all. This is Dr. Dave Maslock talking about reciprocity.com. The E is written with a 3. I'm a professor of innovation strategy and entrepreneurship. And in this particular video, I really wanted to talk about what is a double-blinded study and, what is a single-blinded study. I'm going to provide some definitions. What is the definition of a double-blinded study? What is the definition of a single-blinded study? And then give you some rationales on why it's so incredibly important to do double blinding as much as possible, or even just single blinding if you can, and why it's often considered the gold standard of most studies. Although it's really, to be honest, it's quite uncommon. It's still relatively uncommon in a lot of different fields, but we're moving towards blinding experiments more and more. So this is part of my Nerd Out Wednesday series where I just talk about anything that I find interesting in science, and I talk about different words in science and stuff. So what exactly is well, first of all, what is a study? What is an experiment that we're doing? So an experiment is where you have a treatment and control group. So you have some people in one group and you have some people in the other group, and you provide a treatment to the one group and you don't provide the treatment to the other group, and then you just see if there's a difference between them in the long run. So you're just looking for, maybe it's the average effect between the two. That is called the average treatment effect, for those of you who are not who are interested in exactly what that is. And maybe the treatment makes, in whatever you're measuring, maybe it makes it higher than the control group, and then you just take the difference between those two, and that's the average treatment effect. You can suggest that over and above the control condition, the treatment actually makes a difference. Well, there's a lot of different sort of factors that go into play in sort of ruling out what is called, validity, or ruling out the sort of possible causes where there could be threats to validity in any sort of experiment. And one of the areas, or one way that you can actually rule out some of these threats to validity, and you can look at my older videos where I get into what I mean by threats to validity, maybe that there is sort of historical chance conditions that are sort of making some sort of factors. Maybe there's sort of maturation conditions. The subjects themselves are sort of getting older or changing, or for whatever reason. There's lots of different sort of things that come into play with experiments, and why we should actually do a double-blinded experiment. So what is a double-blinded experiment? That is where neither the subjects themselves or the researcher over here know who is in the treatment and control condition. And this is a really important thing to rule out a lot of different factors. So to sort of go through what's going on, I'm going to start with a single blinded study and explain what are the kind of sort of biases that rules out. So a single blinded study is where the subjects do not know, or the people that are being experimented on do not know who is in the treatment and control condition, right? So they're randomly assigned the treatment and control condition, and they're not told who is in the treatment and controlled condition, right? And sometimes you have to do sort of kind of tricky things to sort of, so they don't know who's in the treatment and control condition, right? So for example, if you're testing a pharmaceutical on pain relief or some sort of pain reliever, and you want to make sure that the control condition is the best available on the market, pain reliever in the market, and then you're testing a new drug. And the reason why you want to do that, and you want to make sure that the pills look identical, and you can't tell what is which one is which, and you're just taking the same doses all the time. And the reason why you want to do that is because sometimes people will guess those kind of things, and they will try to help you out, as the subjects are always trying to help out people, particularly if it's something like that where they know that it's sort of sensitive. Maybe it's some sort of, I don't know, maybe you're testing something like love or something like that, where you're trying to look at the effects of one thing over the other, and you're trying to see if it affects love. Well, they might respond in a way that they're trying to appease the researcher, if they know which condition they're in, right? So there's what is called the social desirability bias. They're trying to appeal to the researcher and say, you know, what I'm doing, this is the right thing I should be doing. And if this is the right thing I should be doing, I'm going to guess that I'm going to try to do this, and it's going to help out science, and it's going to make everybody sort of better off because I'm trying to help out as many people as I possibly can. There's other things like the placebo effect and the Hawthorne effect, which are kind of similar. The Hawthorne effect, that is from years ago in what am I thinking of? In a plant, in a large plant, in a manufacturing plant, they're doing experiments on like lighting and things like that to see if it's going to affect productivity of individuals. And they know that the people knew who, when they were being experimented on, by the levels of light that was going on in the plant, and every time that the light would change, that they would respond by actually getting more productive. And so what was happening was they weren't responding to the sort of experimental conditions at all, but they were responding to the fact that they were being tested on. And that is a really important thing to rule out. You want to rule out that particular effect. So the placebo effect is very similar in the sense that people are going to respond if they think they're being tested on, that they are going to, they're still going to respond in some sort of way, right? So you can give them a placebo, like a sugar pill, and they're still going to respond as if they're being tested on. And that effect is really incredibly strong, and it fools everybody. It fools even sort of really smart people. It fools, you know, the researchers and all that kind of stuff. Anybody that sort of knows the effect even is going to fool them. And it's really incredibly strong, and it can sort of, it can control for a lot of different things, but just knowing that you're being tested on, because people like to help other people out, they like to be tested on, and you know, people are really decent in that kind of way. They want to sort of help other people. So you want to rule out those sort of possible effects as much as possible, right? So a single blinded study is where you just simply do the randomization across the individuals, the subjects, and that's going to rule out all of those different sort of effects of the individuals that are getting those that are getting experimented on. They're going to rule out like placebo effect, Hawthorne effect, and social desirability effect. The other thing that the sort of next level up is the double-blinded experiment, and that is where neither the researcher or the subjects know who's in the treatment control condition. And the reason why you want to blind the researchers, or the researchers, you know, the plural, is because we have all sorts of biases, right? I'm a professor of innovation, and I kind of do, you know, I do a lot of research and stuff like that. We have all sorts of biases. We're trying to, you know, we want our things to work out, right? So we have a confirmation bias. We strongly have a confirmation bias. So if we create a hypothesis, right? So what is a confirmation bias? That is where you create a hypothesis of the way that the world works based on existing notions, existing knowledge, and then we want to make sure that that hypothesis is confirmed, right? The goal of science is not to confirm the hypothesis, it's actually to rule out that hypothesis, to say that, no, this is not the way that the world works in some sort of way, right? We want to rule out that hypothesis. That's what we're trying to do. And if we're so strongly willed to sort of support a hypothesis, then it's going to happen unless you sort of control for that. And the reason why we have all of these biases, confirmation biases, you know, we have lots of pressure to get publications, for example, and the way you get publications is to find interesting results, confirmed results. We have, you know, you just like to have your thing work, right? It's often not fun if it doesn't work, what you're working on. There's all sorts of strong biases. You know, we're curious to see how the world works, and if we can't get anything that's significant, then we just are not explaining that the world works that way, right? So our knowledge is sort of disconfirming. And we don't like that. It's not a nice feeling. So we want to rule out those particular biases as much as possible. So we want to rule out the researcher and make sure that the effect is kind of averaged out across the researchers, that there is no sort of biases that are coming into play. So you just randomize. Because if you think about it, if you have a random population and we're all trying to sort of appease people in different ways. Hopefully people are so random and so different that we are going to appease people such that all of that is sort of trying to confirm our own notions and stuff are going to rule each other out. So it's going to be just average noise, and we can control for that and get rid of all of that stuff. So who uses blinded experiments now? Why? What fields are really important? Blinded experiments are really important in psychology, right? So often people that are in psychology, they might sort of want to understand what a double-blinded experiment is in psychology. They're really important in marketing. They're becoming much more important. They've always been very strongly important, probably for the last, 30 years, 40 years, in medical research and clinical trials. Blinding is really, really incredibly important in clinical trials because we want to make sure that the pharmaceuticals, for example, are that there actually is an effect there, right? That's why it's so incredibly, that's why we pay so much money for pharmaceuticals. It's really hard to often find these effects because we have such rigorous studies, and that's a good thing. We want that. We want to pay a lot of money for pharmaceuticals, by the way. Because that is ensuring that there's good science going on. Good science is really incredibly expensive. And, it's just the fact of it. It's really incredibly expensive to do things to do things right and to do things sort of methodically. Now, it's also moving into all sorts of other fields. Double blinding is becoming popular in my field, strategy and innovation. It's becoming popular, increasingly more popular in sociology, for example. It's still blinding the actual experimenter themselves. It's also been popular in the natural sciences, right? Because the natural scientists, they themselves, so natural sciences being people that are interested in physics and chemistry and all that kind of stuff, they're so eager to actually get a result as well. The researchers are so eager to get a result that they're likely to sort of mess around and have confirmation biases as well. So you want to rule out that effect as much as possible, right? You want to rule out all those possible sort of biases, confirmation biases, placebo bias, placebo effect, the Hawthorne effect. You want to rule out all those things as much as possible. It's so incredibly important. What do you so what do you do? How do you actually do how do you actually do sort of blinding? What's the sort of procedure to actually blind blind your experiment, right? So you want to make sure that there's a random, so the people that are in the treatment group are randomized, people that are in the control group are randomized, and you don't know who is in which group at all, right? So the single blinded experiment is pretty somewhat easy, where you just go and you create in an Excel document to do the procedure for double blinding or blinding. What you do is you go into an Excel document and then you list out the different subjects. It might be subject 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you use the random number generator, which is equal rand, R-A-N-D, colon, or brackets, and then you hit enter for all of those different subjects, and what you're going to get is a random number that's generated between 0 and 1. And what you do is you pick all the ones that are above 0.5. Those are going to be, half of them are going to be above 0.5, and the other half are going to be below 0.5. And that is going to get you a random selection. That's going to be the random number generator that you have. And that's going to get you random selection in the treatment condition and the control condition. And normally what you want to do, if you're doing any sort of experiment, any sort of thing, the general rule is you want 30 sort of things, 30 samples. People, I don't know, maybe you're measuring, if you're doing sort of a science fair experiment sort of thing, you want 30 pieces of ice, for example, in the treatment condition, 30 pieces of ice in the control condition, and you're going to put salt on the treatment condition, right? So you want to see if it actually goes quicker or not, right? And the reason why you want 30 is because at that point, if you have a sample of 30, the average that you get, so if you do an average, right, we heard of class average, for example, that average is going to be statistically at the, you're going to have enough samples that it's going to be at the sort of true mean as we think about it. And I'm not going to get exactly what I mean by that, but basically you need 30 and 30 in each group. And if you start having more treatments and more, you just want to experiment with a lot of other things, that number's got to grow substantially as you get more and more treatments, more things that you're exploring. And there's a lot of stuff to sort of factor in with those, right? So to do a double-blinded experiment, this is a little bit more tricky, right? What you can do is, because the experimenter themselves, if you're the only, you need more than one experimenter of some sort, right? As far as I know, right, you're going to need more than one experimenter. So you're going to want to randomize the treatment and the control for the subjects, but then you might have maybe 3 or 4 experimenters, right? And then you randomize across those experimenters. You tell them that this is going to be, this group is the condition A and the condition B, and you don't tell them what is condition A and condition B, right? And the reason why you want to not tell them is because then they're going to sort of, even if they try to guess which one is the sort of treatment, then that treatment, that there's going to be enough people in that sort of group that the effects are going to be washed out in the long run. And so, ideally, you want 30 experimenters to do this, because then all of that is going to be a wash. But that's really not feasible. So even if you have 3 or 4 different experimenters that don't know what are the treatment control conditions, that's going to be the way to go. So if you have one experimenter, you know what is the treatment control condition, and you're probably going to, you're going to bias the effect in some sort of way. So you're going to need more and more experimenters. You could see how expensive, why double blinding actually gets really, really expensive after a while, right? It gets really complicated. You just have a lot of factors in play that you're trying to look at, right? So there's just lots and lots of different factors in play. And it gets very expensive because you have to pay for those individuals if you're doing sort of clinical studies, right? So that's it. Hopefully you like this video. And what I did in this video, again, I defined what a blinding is, what is a double blind experiment, what is a single blind experiment, why you want to do blinding in different ways, and who actually uses the blinding, who actually uses those in sort of experiments, and then how do you actually, what is the procedure to do blinding of experiments, a single blind and a double blind experiment. So hopefully you like this video. Give me a thumbs up if you like it, as well as watch some of the other videos, particularly if you're interested in stuff about science. Check out the Wednesday ones, as well as I put out things about innovation, strategy, writing, being an academic writer, getting into graduate school, all sorts of crazy stuff. So that's it. Have a wonderful day and take care. Bye.